My name's Graham Zabel. I run our DevOps practice at Devo Team. I've been there about 5 years, just over 5 years. Today, I want to talk about DevOps and data practices, how we can save cash and carbon. So this is my agenda. We have a data problem. I'm going to talk about that. I'm going to revisit very briefly my talk last year on storage is cheap, where I hopefully argued that it's not as cheap as we think it is. Talking about dark data, some DevOps anti-patterns, some data anti-patterns, and hopefully what we can do to address some of the problems that we're facing with data. Nice exponential graph of the volume of data created and replicated worldwide. The y-axis is in zettabytes. Anyone know how much a zettabyte is? Trillion gigabytes. A trillion gigabytes. So this little bar here of 2 zettabytes, that's, just to put things in context, roughly equivalent to the entire storage of all our mobile phones in the entire world. And we're now in 2023, and we're going to grow by about 27 zettabytes in the next year, they predict. Now, this exponential graph, more data, we need more data centers to house this data. Data centers require electricity, and electricity generally emits carbon emissions. I've had some debates with some people even within my firm, a guy in our Google practice who says, well, Google's data centers, Google and Microsoft are talking about net zero. They're going to be net zero by 2023. Well, Microsoft is talking about building mini nuclear reactors to power their data centers. And I would argue there's going to need to be an awful lot of renewable energy to power all these data centers when potentially that renewable energy should be used to replace oil and gas, not to be running our data centers. So I think at some point, maybe next year, there's a talk about humans versus data centers in terms of electricity. So not only, so part of this data problem is AI, and this is the AI part of my talk. This is from a study from a grad student at the Amsterdam School of Business. He published this last week, saying in his medium projection, AI is going to use as much electricity as Argentina, Netherlands, or Sweden by 2027. On top of that, we've got Bitcoin, streaming, gaming, etc. And now we face another problem in that a lot of our electricity grids are hitting capacity. So there, you may have remembered some news from last year, July last year. We had run out of electricity capacity in West London. So the West London corridor, the M4 corridor, is, I just found this out last week, is apparently the second largest concentration of data centers in the world after Virginia. And there is no more capacity to build data centers. In fact, there's no capacity to build housing in some boroughs in London anymore. The same goes in Amsterdam. Amsterdam is at capacity. So we've got this huge growing volume of data requiring more electricity, and yet we are hitting capacity in some of our electricity grids. The problem continues. This is a report published by NTT, a Japanese telecoms company, last month. These reports are coming thick and fast. This one's about the environmental cost of data, where this is a survey for several hundred CIOs, CTOs. 2/3 of them responded that navigating their data complexity is one of their top sustainability challenges. And 40% of those people didn't know what to do about it. They didn't know what the approach is to take. So hopefully, I'm going to come up with some suggestions today. Last year at SEACOM, I spoke about storage is cheap, and I used this picture as an analogy of a warehouse, a store. So whenever we get a new application, a new DevOps tool, a new computer system, generally we start out with an empty store of data. And as we use the system, data starts flowing in, and this data store gets bigger and bigger. And it's very easy to get data into these systems. It's very hard to get it out. Why? Because we often don't know which data is important. The data is often missing tags, labels, or owners. A really big one is what gets into production stays in production. And then finally, there's FOD. Anyone know what FOD is? That's good. I didn't think so because I made it up. But it's fear of deleting data. And I will get to that in a minute as well. So what happens is these data stores get bigger and bigger and bigger until they look like the virtual equivalent of this. And again, I used this photo last year. I didn't get any image rights. I was hoping it was an open source photo. So this year, because we've got Gen AI, I went to Gen AI and said, please build me a picture of a messy warehouse from the inside, 3 stories high with lots of boxes with no labels. And this is what I got. So I thought this is nice. Dark data. Anyone heard of dark data? Heard of this term? Yeah, I only came across this term earlier this year, and it's been on my mind frequently since then. Dark data is essentially the stuff that's in those cardboard boxes on the 3rd shelf of your warehouse that don't have any labels on and no one knows what's inside. So we've got dark data. Wikipedia says the definition is data which is acquired through various computer network operations but not used in any manner to derive insights for decision making. In that same survey, I just talked about the NTT survey, 60% of these CIOs and CTOs said their data, the CIOs, CTOs in the survey said 60% of the data in their estate goes unused. And then this is a quote from a book by Jerry McGovern, Worldwide Waste. I know Barry's tried to get him to speak here, but he doesn't want to travel. He's in the US. He's saying that 90% of our data is never accessed again 90 days after it's first stored. So we've got this massive growing amount of data requiring lots of electricity, and we don't use potentially half of it. Can FinOps help us? Well, FinOps has lots of great, FinOps is essentially a proxy for cost and hence for carbon. So can FinOps help us reduce our costs and hopefully our carbon? And there's lots of great FinOps practices that you read about in the web. The hyperscalers will talk to you about savings plans and storage tiering and get rid of unattached volumes, etc. The one thing they never say is store less. They'll never tell you store less. In fact, again, talking to my Google tech colleague at the office, he says Google's philosophy is don't delete anything. Archive it. Why do you need to delete anything? We could just archive it. Storage is cheap. We'll just archive all the data. So those Office Christmas photos from 2018, don't delete them. You can archive them. You may need them at some point in the future. So there's a fundamental disconnect between the objectives of the hyperscalers and large enterprises who are being told to save money and reduce carbon. Our interests are not really aligned in that case. I want to move on now to talk about some DevOps anti-patterns that I see in the DevOps world that are causing a lot of these data issues. The first one is data explosion through automation. So when DevOps first started many, many years ago, we were in a place where we were doing manual builds, manual deployments, manual testing, and all of these things we would do once a day or once a week or once a month. Now that we automate this stuff, these things are happening every 5 minutes or every code check-in. All of these automated builds, automated deployments, automated testing, they all produce data. They all produce output. They produce binary artifacts or test evidence or documentation, et cetera, et cetera. So if you don't get a handle on the outputs from all your DevOps processes, your data starts exploding. Second one is what I call the bad data virus. So a couple of months earlier this year, I've been working with a client on service design, helping them understand their services, helping them get to a target state set of services. So we've been working with their CMDB, Configuration Management Database. If you don't know what that is, it's actually ServiceNow. I didn't put the logo on. And the CMDB is where you keep your service data. So when I was looking at their service data, 1/3 of their services had been retired for 5 years, and in fact, were owned by a company that they'd sold off. So these services did not exist, the infrastructure no longer existed, the people didn't exist, and yet they were still in this database. And at the same time, they had a program to migrate to a new instance of ServiceNow. So I thought, why don't we clean up this data before we lift and shift it to the new instance? And there was a particular record that was bugging me because it had the same name as a service that was live in production. So I thought, what I'm going to do is I'm going to delete this legacy retired service with the same name as a live one and see if that works. We can go back and start cleaning up all of these old services. So I deleted this one service. All looked good. It didn't flow down now to the next one. But the next day I went back and looked, and the service had reappeared. And I thought, I just deleted this. So what I just then found out was it actually wasn't the golden source of our service data. There was another upstream system, which was the golden source. So I thought, wow, that's cool. We need to clean up the data at the golden source. And I wrote an email to all the people involved, and I said, hey, did you guys realize we've got an upstream system feeding all this this old data to ServiceNow, which is then getting replicated to the new instance? And I thought this was a great discovery. I'm going to get a pat on the back and say, well done, Graham. But what happened is the next day I got a phone call from my stakeholder, and he said to me, we've had a complaint from one of my team saying to me, who is this consultant that's going into a production system and deleting production data? Because I deleted a record. Well, I said, well, it's back again. But that didn't matter. I was in there deleting production data, which, I got a slap on the wrist, but it was, I could have potentially lost my job there. But so not only is this data flowing to a new ServiceNow instance, they also had some homegrown discovery tools, and they were in the midst of a migration, so the CMDB was flowing into these discovery tools. All of these databases were being backed up, no doubt. And then there was also a downstream feed to Snowflake, a data lake, which is, of course, on highly available architecture, at least on three instances across 2 AZs. So when you think about this bad data or this old data, it's potentially a magnitude bigger problem than you think it is if you don't clean up your golden sources. And then finally, the third anti-pattern is delete nothing ever. Well, that comes from the last one. As you can see, if you delete stuff in production and you make a mistake or you rock someone's boat, you can get in a lot of trouble. So it's very much easier to say, let's just leave it there. Let's just leave it there, we won't get into any trouble. And there is, of course, FOD, the fear of deleting data. So if you look at all these tools, I mean, these are typical DevOps tools. If you think about, say, Jira, what do we do with Jira tickets that are 2 years old? Some of the older ones in the room might remember when we had Kanban boards with to-do doing done on the wall with Post-it notes, and at the end of the sprint, we put the Post-it notes in the bin. But now we keep the Jira tickets forever. So maybe there's some kind of happy medium. GitLab repos. What do you do with code, proof of concept code that a contractor's written 5 years ago? It's now in your production system, and it's never going to go. It's just going to stay there, even though it's never been used. Artifactory. I've seen instances where people have misconfigured their builds so that every build is pumping out a release artifact. And by definition, release artifacts are never deleted. So you can get these Jenkins servers that are pumping out release artifacts every 5 minutes into an Artifactory instance, and as they're marked as release, they're never deleted. So you can get hundreds, if not thousands, of these artifacts polluting our artifact system. ServiceNow, what do we do with change and incident tickets that are 2 years old? And Datadog, I think a lot of you may have heard of stories about people getting 7-figure Datadog bills with all the data in them. Now, ironically, all of these tools are meant to be helping us be more agile, and yet they are very unagile themselves if you don't manage them properly. Some DevOps engineers do, a lot of people don't. And if you mix, by the way, delete nothing with data explosion through automation, you get a real data party. Okay, so we've learned we cannot say delete. We get slapped in the wrist, we possibly lose our jobs. So what do? Let's call it data management or sustainable data management. So what do I mean by data management? There's 4 points. I'm going to work backwards. Automate your data management process. Well, this sounds great. Let's get an AI to clean up the data. Yeah, why not? Now, the trouble is AIs need to know what data to keep and what to get rid of. And this, for me, is almost the most fundamental point, is we need data retention and deletion policies. Now, companies are getting better at this. Because of things like GDPR, we're starting to know what to do with, say, customer data, credit card data. We've got good policies. We've got this right to be deleted. So most large enterprises now will have some sort of data retention team that can manage this. But if you go to that team, as I have done, and say, what do we do with Jira tickets? We don't know. There is no regulation for Jira tickets. There's no one to tell you, you need to keep these or you can get rid of them. So we need to be opinionated about this stuff. We need to realize we probably don't need Jira tickets that are 2 years old, and we can start automating policies to do so. But even to have those policies, you need to have some sort of data classification scheme to help us understand who owns this data, is it important, what does it do, et cetera. And then even at the beginning, you need a data audit to understand what all your data is. So if you just think, save 50%, we all would love to save 50%, we could potentially be saving lots and lots of money and carbon if we could have better data management practices in our enterprises. Yesterday, I was doing a mandatory training course at work on sustainability and green IT, green ops. And I was doing this course, and they were talking a lot about hardware efficiency and software efficiency. There was no mention of data efficiency, so I gave the course a low scoring. But they had no mention of data efficiency, and they were talking about things like, let's shift our workloads to where the wind's blowing or where the sun's shining. And I'm thinking, that seemed like a really complicated way of saving carbon when we can just clean up all of this dark data with good, sustainable data management practices. That's it. Thank you.